Hey everybody, we'll be letting people come on here for a second.
Oh, that's good.
He's waiting for them. Oh, they're here.
Since we have so many people in this class, maybe keep yourself muted when you're not actually talking.
Grandma's on class.
Give him a level, please. Yeah. Give him.
Let's see, while you guys are coming in, I'm also trying to look to see where, so I know this thing stores. Oh. It's getting pretty close to everyone. So we have another couple of minutes, so let's just hold on just a couple of minutes. Okay. Okay, so I think we can go ahead and get started. I did mute everybody because there's just so many people that it's like if you have yourself unmuted, there's gonna be too much background noise. So when you want to talk, you do have to unmute yourself again. Dismiss that. I think I'm gonna see what happens after this meeting. So it should be saving it to so that I can share it with you afterwards. I'm not sure we're going to do that much in this meeting that you will want to see again, but perhaps. And I think it will kind of keep a roll for me. I'm not sure. Otherwise, I might have to take a roll. So this is really large for a graduate class. I have another graduate class right now with 4 students, and like 6, 8 students are okay. 19 is really a lot of students, right? So one thing that's going to cause is it means as we do the homeworks, as we go through the class, there's no way I can grade all of your problems completely, right? Because sometimes each problem takes quite a while to grade. So I'll have to see what I actually do about that. For the current things, I'm some of you might say I've already graded some of the stuff you are turning in. For the written things for grad school, I'm basically saying in the comments to ask me questions if you have questions about them. For the paper itself, I'm going to basically run those, give the prompts to chat and run the papers through chat and say, did they do everything they were supposed to do, right? Without looking at that too much. I'm really here mainly for the math side of things. This is not a course I usually teach. I usually teach 513 and 512 and 571. Those are the courses I teach. I'm not the only one who teaches those. There's a few of us, so we trade off on classes. I happen to have a 513 running at the same time. Just got them to move it to Tuesday so that we could meet today, right? Okay, that's a good question. Can people hear me? Can most of you hear me? Okay, so someone just wrote and said they couldn't hear me, so I think that must be a unique thing on your end. So maybe check your volume and stuff. So Crystal Morgan. There are so many people here. There's Jordan. Where's Crystal? So Crystal, I'm looking at you. Can you hear me now or not? I think Crystal cannot hear me. Okay, hold on just a second. Let me write something to Crystal here. Okay. Okay. So so I'm not really that great at being able to keep track of the chat along with everything else. So if you do write something in the chat and you are hearing me, then you might want to poke me to say, hey, I'm writing something in the chat for you. Anyway, gee, with this many people, do you want to take just a second and introduce yourselves? Those of you who can talk, we'll tell you that's our participation today. I'm going to start around my screen and just so LaDonna, so I'm Richard Kettersid. I gave you my bio. I'm assuming you've probably read it. So I've got my PhD from UC Berkeley and I've been teaching here for like 10 years. And I'm one of the main people in charge of the graduate program. So creating courses and setting up courses and all that sort of stuff. 509 is a course that I created many years ago, but haven't taught since it was created. So someone else has gone and changed it quite a bit, which is fine. But it's actually the first time I've taught it in a long time. This new online version of the class is pretty new. And so apparently it's taking off. I mean, you're a big group of students, so we'll see. Hopefully you can last, right? So this class is pretty not too rough, I think. It should just get you going. The next class will be history of math. That should also be fun, but maybe a little bit more on the work side, and then you jump into the real stuff, which is linear algebra and abstract algebra and real analysis. So that's the more serious math classes. Anyway, LaDonna, you want to say something about yourself?
I think I pretty much put everything into my bio. If you all read, hello, you all. My name is LaDonna. I'm here in Texas. I've been teaching for I think 20 years. 20 years,
Wow.
but not so much a teacher anymore. More of like a facilitator, try to help kids get back on track with their graduation rate on plan. I'm here to try to finish up my degree, as I stated in my bio. Just little introduction thing. I'm just trying to get back my degree in mathematics. So I can move on to a college level to teach higher level math. So this is something, one of my dreams that I always wanted. I eventually want to be a doctor in mathematics, but I don't know. But I'm gonna see how this right here goes. I plan on finishing this time. I'm hoping it ends August 2026. I'm thinking that was the schedule thing. Say August 26. I'm hoping that, finger crossed, I get it pushed through, and I'm hoping with y'all help I can get it. And I'm like you so far, Dr. K. I'm hoping I get you in 513 and all your other classes. I do have a question though for you before I go. With the discussions, do we have to reply back to one student everything? Do we have to do that every time?
So this is a good question. For the participation in this class, the main thing is this meeting, okay? And then the other thing that I will do in the future is I will post like a reading quiz so this week I posted notes and videos and stuff like that, right? So I'll post like a little Google Forms type quiz, right? Some true false, some multiple choice, things like that I would like you to try to do before we actually meet in class, right? And then so there's 20 points a week on participation. Part of that will be for filling out that thing prior to class. Part of it will be for coming to class and participating, right? With this many people, it'll be really hard for me to maintain like any real thought about who's participating, right? But I will, if I don't get it, because I'm pretty sure that when I finish, it'll save me a list of who all participated. So that'll be great. If not, I'm going to have to like do something at the beginning of class to take roll or something like that. Anyway, I think that answers the question. So let's go on. So Oh, there was one question. So that's a good question. As we go around, you brought up a good point. You're actually wanting to teach like at the junior college or college level. Is that what I'm understanding?
Yes, sir. Just a
Okay.
higher level. I was doing the DMAT classes at the college before COVID. I did the DMAT classes and stuff like that, the intermediate courses. But since COVID, they took those positions, gave them to all the not football, all the full-time employees. So it's hard to get a DMAT position when all the full-time employees actually can
Okay.
do it online. Everything is done online now, so it's really just hard to get it if you
I
just
see.
just
Okay.
got a
Okay.
BS in there.
Okay. Well, it's good to know who's doing that kind of thing. So I mean, that's I mean, there are two kind of potentially different groups of people in the class: those who want to go on and teach at the college level, uh, and I guess those who also want to teach like dual enrollment type classes in high school. So you're teaching both in high school, and then those who are just getting a degree to I don't know, get a pay bump or something like that. But you're really not planning on teaching college level classes, right? So those do kind of split you up into two different groups of students in some sense. Maybe let me move on. So Philip, tell me a little bit about yourself. This also gets to check our
Okay,
technology.
yeah. Hi everyone. I'm Philip Dangladi. I'm actually from Nigeria. I just got to the States last year, November. Uh, Um, so I've been teaching in my country for like since 2014. So yeah, and I've been teaching the subject mathematics because I have my BSc in mathematics, and I actually want to get to the PhD level. Yeah, I want to be a doctor in maths.
Oh,
So
okay. Okay.
yeah, so I'm hoping this is just like a stepping stone for me, to
Mhm.
get to that particular height. And I'm also a high school teacher in Florida, in Hollande High School. I take grade 11 Algebra 1, and I take calculus for grade 12.
Okay.
So, yeah.
Okay. Good. Good. All right. Interesting. All right. Good to know your plans for the future. That's a good thing. All right.
Yeah.
Cassandra, you want to say a little bit about yourself?
Is my microphone working? Because I wasn't
Yes, it
sure.
is. Yep.
Okay. Yeah, I'm Cassandra. I'm trying to get my master's really because I want to eventually teach college as well. Right now, I teach high school, but at a special needs school. So I don't just teach like a grade level. I teach Algebra 1 and geometry, but I've got kids that are in ninth grade and kids that are on like their second, third round of senior year. So it just kind of depends on where they've fallen. I live in Florida, and I also like to write books and stuff on the side, but eventually I want to teach higher levels algebra. I'm not sure quite where at yet, like where I want to land, at how far up the math ladder I want to go, but I just really like learning new math too. So I'm also here just to learn
Okay.
more.
Good. Well, that's a good reason. All right. Awesome. Hugo, let's see if your stuff's working.
Right. Hello.
Yep, we got you.
Right. Let me see. My name's Hugo. This is my probably third year teaching. Uh, and my reason for doing this course is I want to eventually teach, at least at the beginning at a community college, teaching
Okay.
mathematics, and then hopefully university level. So
All right. Okay. So that's a theme this time around. All right. Caitlin, do you want to say something?
Hi, can you hear me?
Yep, we can hear you.
I'm Caitlin. I live in Tucson, Arizona. This is my second year teaching. I'm taking a master's in math because I plan to take over the dual enrollment classes at the high school I teach at when my coworker retires. At some point, I would like to teach some college math classes, but not sure when that would be. But right now, it's just the plan to stick with high school and teach some dual enrollment classes.
Okay. Awesome. Awesome. I taught at Pima for a while, by the way. So
Oh, cool.
yeah,
I
we
went
moved.
there. I went there first semester.
So when we moved here, we moved to go to Tucson. That was the plan. And ended up in Phoenix, which is a common story.
Yeah.
All right. Pringle, you want to say some stuff?
Sure. I'm Tringle Witt, and I've been teaching high school for 13 years, 12, 13 years. I teach dual credit classes. I got my master's in curriculum development, but there's just not enough rigor, not enough good mathy stuff. And so I'm not sure where I want. I just want to open a bunch of doors, and I want to kind of play in the math world for a while and kind of see where I want to go from here. So
All right,
options,
cool.
I guess.
Good, good. All right. So Cami, you want to tell us a little bit about yourself? This is also a quick check on everybody's speakers and things, right? Good. All right. You looks like you came on.
Okay. Hi, I am Cami. I have been teaching for 5 years now. I teach at a really small school in Southern Illinois, so I'm pretty much the math department in the high school, so I teach pretty much everything. So my goal is to be able to offer dual credit classes at our school because I don't think they've ever been able to offer dual credit classes.
Great, great. Okay, good. Melissa. Yeah.
Hi, everyone. I'm Melissa. I guess a little bit about me. I'm in the military. I'm in the Navy. I'm stationed out in California. I was going to school for my bachelor's for secondary education to teach at a high school to teach math. But being in the military, I can't do the student teaching. So I ended up getting my bachelor's in educational studies, but I still wanted to teach math. So I heard that if you get your master's, that you can teach at a college. So I was just like, okay, I'll do that. And in the military, you need to go to school to, like, I guess, be competitive. So I was just like, they're paying for it, so why not? And I'm able to do it. So that's why I'm here.
Oh, that's good. That's good to know. I didn't know that. So that's awesome. Good. All right, Crystal, you want to tell us a little bit? Oh, and you can hear me now, right?
Yes, sir, I can hear you now. I've been in public education since 2001, with a small stint in the professional world before coming into public education. I've been an instructional coach, I've been a coordinator, and I really just got frustrated with the politics of being a administrator in education and decided to return back to the classroom. I feel like sometimes the administrators really don't understand what teachers go through and the gaps that they have to face when they are dealing with students in the classroom and parents are disconnected from the teacher and it's very difficult to connect with them. So I really try to burn a fire under my students and create a connection for them that gives them a love for math. And it just reminded me that I had 4 specific teachers whose name I still remember to this day, back from 6th grade, high school, and 2 from college, who just made learning math like the most, it made it like crack. So math for me is like crack. I'm addicted to it. I love it. I love to learn. As I was reviewing everything, I'm like, I don't know this. Ooh, yay, I get to learn. I get to learn something.
Oh, good.
So the first assignment of coding, I was like, I don't know what this is, but I was so excited because I was struggling. And that's what our students feel. So just having the opportunity to experience being a student again will make me more empathetic to my students and help them pursue their goals.
Yep. Good. Awesome. Okay. Beverly, you want to tell us a little bit about yourself? Can you get your mic on? Can you hear me, Beverly? Or maybe Beverly Hall Hamilton. I can't actually see you terribly well, so I'm going by Beverly for the name.
Trying to get to you.
Okay. I think I hear you now.
You hear me now? Okay.
Yep, I'm hearing you.
Beverly Hall Hamilton. I moved to Florida from Jamaica 4 years ago. I've always been a teacher, love teaching, get the inspiration from one of my teachers in high school, and I want to pass on the knowledge. Now, I've always dreamed of getting a master, and I think right now is the most convenient time to do so.
Okay, awesome, good. Aaron, you want to tell us a bit?
Hi, Aaron Luna. I'm from El Paso, Texas. My goal is to get a master's to move up to teach at the community college level and hopefully also open up doors at the local university. Because I currently hold a master's similar to this, but in physics, except typically students don't want to take physics in college. They rather take like geology or biology. And since I'm comfortable in math and love learning about math, I always felt like I should have just been a math major to begin with, than a science major. I feel like this is the right time and right opportunity to do so. And so just like most of everybody here wanting to just learn math and get to another level to be able to teach comfortably to students and have them understand it as well as we all try to.
All right, awesome. How about you, Madison?
Hello, I'm also living in El Paso, Texas. I am currently doing my 4th year of teaching. I teach the freshmen in our early college program, so eventually I want to teach the dual credit.
Okay. And Allison?
I'm busy. My books are busy.
Sorry, I'm hearing a lot of noise in the background.
Yeah, I'm wondering, where is that coming from? Oh, here we go. Okay, there we go.
Okay, thank you. I'm Allison Bjornson. I graduated with my bachelor's in December of 2020. That's when I finished my student teaching. So I got to do my student teaching in the midst of all the craziness. I have worked the last 4 years at White River on the Apache Reservation, an hour from my home.
Okay.
I am realizing now that I'm going back to school that we struggle so much with our students just understanding the basics of mathematics. I teach geometry and algebra too, but I'm having to do so much with the basics to even try to pull them up to the level that we're at, that I'm realizing I do not remember nearly as much as I thought I would on all the proper formatting in the math. And I know that that's what overwhelms me with it. And that'll be my struggle in math. I can do the math really well. Proper formatting, I might struggle with a little. My life is crazy. I am I'm a mother to my son who's a special needs severe autism kiddo. So in addition to working full time, I have all of my son's special needs as well. So things can be a little bit difficult with timing. I will try to make sure on Mondays I'm on time, but I usually don't get home until right about 5, just after 5. Are there any issues if I'm, say, maybe 5 minutes late? Would there be any problems? Okay.
No. I mean,
okay, thank you.
Yeah, I think, like I said, I think this will keep me a list of who's here. Otherwise, if I check roll ahead of time, just make sure that I'm catching it, after the fact.
I appreciate that.
I'm really bad with, especially with this many people, like just keeping track of who's who and where everyone is and all this sort of stuff, right? But yeah, 5 minutes, 10 minutes, that shouldn't be a huge problem, right?
Okay, perfect. Sorry, go ahead.
I was going to say these should be recorded, so you can always catch up on whatever it is you missed in the first bit. Should be the
thank
case.
Yeah, I do get the large class sizes because most of our classes are about 40 to 45. I end up with 150 to 200 students between 5 classes.
That's insane.
There's a reason I'm ready to be at the college level.
Yeah. I mean, it happens at the college level too, but then you usually have other people to take care of some of the grading and stuff. It depends a little bit. At community colleges, they usually keep the classes a little bit smaller. Right.
Yeah, and we also at the community level don't have to deal with all the parents and issues that can pull from there as well.
Yeah. Imagine I have a daughter who's in high school now, and so there's a daughter with a math professor for a parent. I'm terrible.
I love parents like you. It's the fact that a lot of our parents don't care and then get mad when it's time for basketball season that their kids are failing and try to force the parents to pass them. That's my problem.
Yeah, there are different ways of being a bad parent for teachers, right? Okay, good. So Dina, you want to tell us a little bit about yourself? Or Dina, I suppose Dina?
Yes, Dina. Okay. Hi, everyone. My name is Dina. I have 16 years experience in teaching high school, and I started my career was a little bit high. And then when going down for high school, I taught in engineering university for 3 years in my country. And
Oh,
then
wow.
when I moved with my husband, so I have to teach high school as a mom for 2 boys, middle school. So the life is a little bit challenging. I currently teach in high school. I'm teaching Algebra 2 and IBAAHL, which is college level. And my dream that I wish since I graduate to have my PhD in math and to teach in UCF now. So hopefully I can reach my dream with all of the challenging going on.
So UCF is where? Where are you?
I'm living in Florida, UCF.
Oh, UCF is
Yeah.
University of what? Florida.
University South Florida. UCF. I actually like don't know, but
Central.
it's the most famous like college here in
It's
Florida.
Central Florida, right?
It's
University of
Central Florida.
Yes.
Oh, okay.
Yes.
Okay.
Yes.
All right.
So
Awesome.
I actually took one course there and like it's in a master in the UCF, but was very challenging with the time. And so I said like, no, I need to be teacher there, but not taking the master there. It's so hard.
Right. Is it in Gainesville?
Can you repeat that one more time, please?
Is it in Gainesville, Florida? What city is it in? What town?
It's Orlando.
Orlando. Okay.
Yeah.
All right.
Yeah.
Okay, good. All right, awesome. So you sound prepared. Megan, you want to tell us a little bit about yourself?
Hi, I am in northern Missouri, small town. Actually just got done at a baseball game.
I was gonna say in a car.
Yeah, I'm in a car. Yeah, this will probably be me every Monday night. I do actually have the luxury of the time change, so the game finished, and 15 minutes later we got the call, so it works out.
Okay.
I've taught for 8 years. I'm getting my master's, so I can kind of go anywhere, be helpful at least. My husband is a college coach, and once our son graduates in 2 years, we don't know where we'll be. So he's kind of on the hunt right now, and this will just kind of make me a little bit more, I don't know, more available for other job opportunities within education. I do want to stay within education, so.
Okay, awesome. Good. Let's see. I think on my sheet, there's a couple of people hiding on the next tab over. So Jordan, you want to tell me a little bit about, I mean, we met already, but tell everyone else about yourself a little bit.
Yeah. So I had the pleasure of annoying Dr. K prior to this meeting with probably a list of about this many questions. And so I appreciate you for taking those questions. But my name is Jordan. This is my 6th year of teaching. I graduated from Prairie View A&M in Prairie View, Texas, small town, in 2019. And at that point, I really felt like I was at the pinnacle of like my mathematical self. Now a little bit older, I do feel like I've gained other skills as far as like punctuality, just diligence, just consistency. But on the flip side of that, mathematically speaking, I think that if you don't use it, you lose it. So a lot of things that I saw initially, like I was telling Dr. K, were kind of overwhelming, but I did have to give myself time to kind of look at those things. I didn't see many of you guys complain about any of the notes. So maybe I'm alone there. So I will definitely be leaning on all of you all to kind of help me in that regard. But ultimately, my goal is to teach at the junior college as well, like all of you. So
where are you at now?
Where am I?
Yeah.
Cypress, Texas.
Okay, because yeah. I'm from Texas too. I'm from College Station.
Oh, nice.
And I actually applied to teach at Prairie View once.
Really?
Yeah. I mean, in a way, I'm glad I didn't get it because I didn't really want to stay in Texas, but
yeah.
Because I like to hike and bike ride, and Texas is not a great state for doing those two things.
Yeah, I think you're in the right place, brother.
Yeah. Good. All right, Carl, you want to tell us a little bit about yourself?
Sure. I'm Carl. I live in northern Minnesota. I taught K-12 for 15 years. I taught a little bit of everything, actually. I'm certified in a bunch of things. And then I'm finishing up my 13th year teaching in higher education. Most of that time has been teaching in teacher ed programs. And then I also, though, did spend 2 years teaching math at a community college. And so I am here to kind of firm up my math background. I had as I sort of talked about in my intro post, I had a very eclectic math journey in getting the 20 some graduate hours I have to qualify me to teach. So I'm going a little more systematic this time. And I'm here kind of for a backup plan. I was briefly scheduled to be laid off from my job, and I decided that I needed some backup.
Okay, interesting. It's a good chance if you already have 20 graduate hours, everything might be mostly review to you.
Well, no.
No? Okay.
It's eclectic. Linear algebra will hopefully be review, but a lot of other stuff should be no.
Okay. Well, awesome. I mean, I know other people have come in with that much graduate credit, and they take the abstract algebra class, and they're like, "Oh, we didn't get through Galois theory," and then they're upset. Because the same thing will happen. I mean, these classes are 8 weeks, so they're really intense but kind of short, right? And so it's hard to get through as much material as you would like to get through, right? In a corresponding, graduate level class, right? So anyway, it'll be curious. It'll be curious and after the fact, right? To have your sort of thoughts, right? Especially after you've gotten into those other classes. Yeah, the first 2 classes are this one, which is just kind of getting you familiar with things, and then the history of math, which is probably a little bit different for people who, or have a math background, right? And it depends on who's teaching. I mean, when I teach it, I put lots and lots of math in there, but I'm sure other people teach it and they put lots of history in there, right? So there's some differences in the ways you can go with that class. Okay, good. So there were some notes, and there were videos with that. I'm going to try to do that every week for some portion of the material.
Dr. K, will we have you for the history? Because I'm not a fan of history, so I'd rather learn the math. I'm just checking.
We never know who's going to be teaching what at various times. So probably not, because they need they need me to teach 513 and 512 and 571. So probably someone else will be teaching 525, which is the history. But I think he's still good. I mean, I think people like Rick, right? So I think that's probably who you'll have. That's my guess. But I think he'll do a great job. So I mean, it won't be just a history class. It'll still be math, right? I mean, I can go too far sometimes. Like, I have you prove that the only kind of constructible polygons are certain kinds of things, right? And actually, like, read Gauss's original paper and stuff like that, right? So you can get really into that if you like it. I do see some questions are sort of popping up along here. It might be easier to just ask those out loud instead of having me try to catch them. I guess I'll let you guys kind of answer each other on that chat, but if something comes up that I need, if something comes up that I need to answer, just let me know.
Yeah, I think we're answering each other pretty much on the thing, unless I see something that you cannot that we can't answer. But majority, I think everybody answering each other.
Okay, awesome. So that's one of the things. It would be nice to keep you guys together as a cohort, right? Once you get to know each other, so you can exchange information and get used to working with each other. And as you move through the courses, as long as you stay, right, you should get sort of familiar with your group of students, right? That would be a nice thing to have happen. Again, this is sort of a new program, and for some reason the schedulers have a tendency right now to spread people around in ways that we didn't expect them to do that. So hopefully they won't do that, and they'll try to keep you as a group, right? And of course, the only thing that varies there is, like, summer comes up and some people can't take some classes and stuff like that. So I mean, things do happen. Anyway, any questions on the material? One thing I'm going to do is maybe talk a little bit about some of what I'm seeing in the homework that's been submitted so far. Some of you have already turned it in. But are there things you would like to discuss from the slides? I do want to talk about the MATLAB and some of that other stuff, right? Just sort of familiarizing yourself with how to access some of these things. But maybe just start with the math side. Is there anything from the math side that you're dying to ask right now? Otherwise, we can go on into some of the tech stuff.
I just had a quick question on the assignment.
Which assignment?
On the Homework 1.
Okay.
When it says thinking about sizes of sets, what are the orders of the following sets? Is that supposed to be a 0?
So actually, let me go ahead and do this screen share thing so I can answer questions. There. Okay, I think you're seeing a shared screen, and then let me just have a second to like rearrange my stuff again. By the way, once I start sharing screens and we got all these videos going, sometimes my computer starts to freak out. So I will apologize. And sometimes I even have to leave and come back in, to deal with that. So this, whoops, this notation like that, right?
Yeah.
Is the same as the empty set. So the set that contains nothing, right?
Okay.
So it's not 0 the number, right? So I mean, this is kind of a funny section because for the formality of math, right? There was a time in history where people did things with numbers and did things with continuity and stuff like that. It wasn't all completely formalized. And so at some point, people wanted to formalize it in a specific theory. And so set theory is sort of the language that underpins all of math, right? On the other hand, it's kind of the part of math that a lot of people can just ignore. Right? You don't necessarily need to use it, right? So this is kind of in here because it's the logic and set theory little introduction, right? And so the point of this little section is, first of all, just to introduce some notation with sets. And secondly, to maybe indicate how you can build the number systems with sets, right? And only the most basic things. So in this case, just building the natural numbers, which for me will be 0, 1, 2, 3, 4, etc. Right? So those things we might call counting numbers. I do put 0 into the natural numbers, okay? And then the negative numbers. And then the next thing to construct would be rationals, right? And so we can talk a little bit about that, but it's kind of like what we call the foundations of mathematics, right? So logic and set theory are kind of the foundational stuff that kind of comes before you start doing things like calculus and algebra and all these other things, right? So just real quick, right? The empty set here is not the same as 0, right? So we think of 0, 1, 2, 3. We think of those as being numbers, right? Now we can represent them in set theory, starting with the empty set. So sort of defining, so one way we could build up these numbers is to say, define 0 to be the empty set, right? And then how do you actually build, like if you're just looking at the numbers, like what are the axioms you have there? We have an axiom like this, and I'm going to use some of our notation. We have an axiom that says for all x, there exists a y, right? In fact, there exists a unique. So sometimes we use this bang notation for unique y, right? Such that y equals sx, where this is supposed to be the successor function, right? So you want to say for all x, there's a successor, right? Something like that, right? And then you want to say things like for all x except 0, right, there's a predecessor and stuff like that, right? So there's a bunch of axioms called Peano's axioms, right, for numbers, okay? And now we want to build those things up inside of set theory, right? So you start with 0 equal the empty set. What do you make the successor? I'm going through this little discussion because this is a thing where people are getting something a little bit wrong. So if I have a set and I want to define what the successor is so that I get a new set, right? A natural thing to do, at least after set theorists invented it, right, is to take x union the singleton x, right, and that's kind of the successor of x, right, in the set theory universe. So 1 here would then be the successor of 0, right, and according to that, it would be 0 union 0. So I'm just making this a little bit more algorithmic than the little example you had in the notes, right? But now what is 0 union 0? Well, 0 was the empty set. By the way, this gets into so in this idea of trivially true things versus vacuously true things, right? A lot of people said that trivially true means just true by the definition. But an awful lot of what we do when we do proofs is unpack definitions, right? You spend a lot of time doing that, right? So in some sense, I'm kind of doing that here. I'm sort of reusing the same definition, this thing kind of over and over and over to introduce this stuff, right? So what does this turn into? Well, this turns into just the singleton with the empty set. So this is not the empty set. This is a set containing one thing. The one thing it contains is the empty set, right? So it's a little bit weird, sort of on the philosophical side, right? So now what is 2? Well, 2 is the successor of 1, right? And so what is that? Well, it's 1 union 1, like that, right? And so what is 1? Well, it's that thing. So it's the empty set union the set containing the empty set, right? And so that is the empty set together with the set containing the empty set when we take that union, right? So, so union, I'm introducing this idea of union. Hopefully that's clear too, right? But I'm taking the things in there together with the things in there. So that's just those two things, right?
Does the union basically mean we're merging them together? We're adding them together?
Yeah, as long as you think of adding is taking everything that is in either one, right? So I mean the usual like Venn diagram type picture, right? I have A and B, right? And I have A union B would be the set of things in either of those, right? So all that stuff there, right? So that's kind of the idea, right? And then we keep doing. So now this is what was given to you. You were given 0, 1, and 2, right? But I want to go into 3 because this is where people start doing the wrong thing left on their own, right? So that would be S of 2, right? And so that is just 2 union 2, according to this way of doing things, right? And what is 2 union 2? Well, that is, this thing is 2 now, right? So that is this thing. Union the singleton of that thing, right? Like that, right? So it's got the empty set, it's got 1, and it's got 2, right? This is what 3 is supposed to be. And so writing that all out, it's this thing. I think I only saw one person actually write this down correctly. And I need to get all the little squiggles in there, right? So that is 0, that is 1, and that is 2, right? And the set of all those things is 3, right? And this, by the way, leads to something else, which is really quite useful. Notice that in defining things this way, we end up with n, whatever the number n is actually the set 0, 1, 2, up to n minus 1. Which actually can be quite useful. I mean, so, maybe it'll come up. It's a very useful way of thinking. And if you do any programming and you use, say, Python, right? This is sort of the way Python works. It starts enumerating at 0 and goes up to n minus 1 when you say do something from, up to n, right? That's sort of the way it does things. Anyway, this kind of construction is what you're doing there. But the point is, this is the successor function. So you're taking the set and you're unioning it with the singleton of itself, right? And that's definitely something which is not x. I mean, let me just point this out too. So Sx is a new thing. It's not equal to x, right? So what that's saying is that x union x is not equal to just x, right? And so this gets into something I had in the notes. When are two sets equal to each other? So A equals B, if and only if A is contained in B, right? And B is contained in A, right? Like that. So every element of A needs to be an element of B, and every element of B needs to be an element of A, right? So the only way these two things as sets would be equal to each other, one thing it would imply is that X, right, would have to be an element of X. So if these were actually the same, we would have that X is an element of X. And it turns out to be one of the basic rules of set theory, one of the axioms, that can't happen, right? You can't have a set which is an element of itself. That's one of the things that sets can't have happen, right? It's called the axiom of foundation. So we're not going into a full course on set theory, but there's a little bit of sort of interesting background stuff that's kind of coming up in here, right? Anyway, hopefully this will help you. I mean, so once you sort of see how to write down this specific operation, right, you should be able to go on and write down what 1, 2, 3, 4, 5, 6, etc. are without too much trouble, right? I think you're only asked to go up to 5 at the most, right? For the way the problem is picked. Any questions about that? That's kind of something most of you have already thought about some. So, and then there's 2 hands up. So maybe let me just get that. Crystal, you had a question?
Well, yeah, but I had a ton that came after that. So, but the first question was, and I'll skip with that one, is do we have to remember the names of all these people that did the different things like D. Morgan and do we have to remember those official names? Do we just have to know the process and know, okay, this is the process I need to switch over to? Or are we going to be testing on who did what?
So first of all, in this class, there's no tests, right? So that's one answer to your question. When you're writing down what you're doing in your work, right, it doesn't hurt to say what you're using. Like if you're writing down a proof and you're using different rules, right, it doesn't hurt to write down what it is you're using. Like I'm using De Morgan's, I'm using excluded middle, right? I'm using something like that, right? Because you need some way of saying that it's justified, right? As you write it down. I mean, you could write down the full proof, like the full truth table every time you want to use something, right? But that would be a lot of stuff to write down. So if you want to say I'm going to use some result, right, like modus ponens or modus tollens or something like that in an argument, right, then you should probably write that down. I'm not sure we actually ask you to do any of that, but it, when you're writing the basic idea when writing down a proof, right, is you want it to be self-contained. You don't want it to have any circular stuff in there, right? Now, when you're writing down a proof, you can use things that are already known, but then you should say exactly what they are, right? And so giving a name is a good thing to do, or giving a reference. If you're doing a higher level class, maybe it's theorem 10.3 or something like that. So you're using those results, right? So you're just letting people know what you're using that you've already learned versus what you're doing yourself, right? I mean, this must come up even when you're teaching, like when you're wanting someone to do an integral, they can't just write down the final answer, right? They've got to do some steps in between. Well, which steps in between do they need to do? They need to do the ones that you think they're supposed to be learning, right? And that's a little bit of a murky issue, right? You're trying to write down, so you should let me know what it is you're using along the way. I don't actually know that we ask you to do that anywhere, but if we did, right?
Well, when I was reading your notes, you showed us an example of a 2-column process proof, and you said that we would not be using the 2-column process proof often. So that's one of the reasons why that question came up.
Yeah. So if you were doing that, that's a good place to put down the name of the thing you're using, right? Because you have to get from one step to the next somehow, right? So it's a good thing to do to write down how you're doing that. And sometimes you do that. I mean, look, we do that in algebra. Here's a simpler example, right? Suppose you're in a class and you say solve 3x plus 2 equals 4, right? And depending on what class you're teaching, right, someone might just write down the answer, right? Or you might expect them to do something like this, right? And then you might even want them to say what they're doing, subtract 2 from both sides. By the way, I will apologize for my handwriting, but that's the way it is.
Or say additive inverse.
Or yeah, however you want to say it, right? But you might ask them to do that step, right, and explain what they're doing in that step, right? And then maybe they'll do something like this. I mean, it depends on how serious you want to get, right? They may do something like this, and you might just say simplify, right? And then they might do this, and you might say something like, additive identity, right, or something, right? And then you might do like this, right? I mean, it depends on what you're doing, right? Okay, and then you might say divide by 3, whatever it is you're doing, right? Along the way, or multiply by the reciprocal or something like that, right? So how much detail you expect there to be there depends on which class you're in and what you're expected to know, right? I mean, you could, in a calculus class, if someone just gave you the answer, right, x is equal to 2/3, right, that's fine. They don't have to show anything else, right? But like in an algebra 1 class, maybe they need to do all this, right? So that's where you have to be a little bit careful, and it depends on the context and stuff, right? And so when I'm grading, that's part of what I'll comment on, right? You need to show more steps, you need to not be circular, you need to something like that, right? It's not a real clear answer. It's always a fuzzy thing, like how much you need to show and explain, right? I would certainly say anything where you're having to think about it, you should write down. And Dina, your hands went from 2 to 1 hands. So.
Yes, I just have like a couple of questions regarding the correction policy. Like, let's say I know it's a big class and sometimes you focus in the specific parts in the homework. What if I miss like answering this part and let's say I get 0? Is there any way for correction or it just keep remaining the same grade?
I don't know. I haven't decided what to do about that. There's just so many of you, right? So, I mean, I'll tell you what I do in my later classes, because that's sort of all I can think about right now. When I have so again, in those classes, usually it's the exams that are graded, right? And those exams are worth 50% of the points, so it's a large part of the grade. On the other hand, about 50% of the points are free if you show up and do the work, right? And so you get 1,000 points in these classes. So you kind of start off with a base grade of 500 points as long as you do the stuff, right? So that's good. It's like 50% bonus at the bottom, right? On the other hand, if the test is hard, you might only score a 50 on the exam, right? So that will bring you down to a C pretty quick if you're not careful. And a C in these classes are basically the same as failing. I mean, you can't get more than 2 Cs, right? So you have to be careful about that. So what I do there is I let them do corrections. So they turn in their exams, I give them solutions. They then do the corrections on their own, but they get to look at my solutions, right? But then I want them to do like we were just doing. I want them to reflect on what it was they were thinking wrong, right, along the way. So I do that for those really large assignments, so 250 points. Now your homeworks are all pretty high points. They're 170 points. They're a little high for what I would like for homework to be, right? So I haven't quite decided what to do about that. So I've graded a few homeworks. It's usually a little easier after I've done a few. And what I've done is I've just taken off 5 to 10 points. I haven't taken off very many. So I would say with what I'm doing right now, I would say no corrections because I'm just not taking off very much at the moment. And so what I might do in the long run is make like every problem you actually do count worth some number of points. Like there's only 3 questions here, so maybe 20 points each or something like that. And then deduct points from those 20 points. So that would be 60 points. The whole homework's 170 points, right? So I'm basically giving you 110 points for turning it in, something like that. It's really hard for me to distribute 170 points on 3 problems, right? It's really kind of silly in a way, right? I mean, you all know this. Sometimes you're just sort of stuck with these things, and that's the way it is.
Yeah, and I ask you a question also regarding the homework format. For the first homework, it's easy like to type and it's the simplest, very easy to use a word or like it's not that hard. But I don't know about the future homework if it will be more complicated as like math language. So it's easy to just print it and solve it and like scan it, or we have to type it. Like if it's hard using math symbols.
So I'm and someone else, Jordan asked me about this earlier today. So part of this class, so again, it kind of depends who's teaching the class, right? In general, I don't mind handwritten work because I actually think it's good to handwrite stuff. It kind of gets it into your brain in a certain way that typing doesn't do sometimes. But there are other people that would like you to type everything, right? So I think Rick, for example, likes you to type everything. And so part of what I would like to do in this class is get you to at least type some of the stuff, right? So go through the effort of typing some of the stuff. Now that's part of the technology we can talk. So here's one option you have now that you didn't have before. You can handwrite stuff, and at least I can. So I have a paid subscription to Gemini. I don't know how it works if you have the free one, but you can handwrite stuff and go to Gemini and say, turn this into LaTeX for me, right? And it will do that. Now it will make mistakes. If it can't read your handwriting, obviously my handwriting's bad, so it would mess up lots of things. It'll just make up stuff, right? So you have to be careful when it does that, but it will do an awful lot of the work for you. The other thing you can do is you can just go into one of these things like Chat or GPT, Chat or Gemini, and type quasi math stuff, and it knows well enough what it is you're trying to do that if you just ask it to convert that to decent LaTeX, it'll do that for you, right? And so now, what is this LaTeX thing I'm talking about? Because you guys are talking about using Word, right? And you're not even talking about using LaTeX. So I'm saying if you're using those tools, it's useful to know LaTeX or markup. So let me show you something along those lines. Okay, so I'm going to pull down one of my Actually, I mean, I can even use the notes I think that I made for this class. Let me find those. Well, here, I'll just pull down this because I have it here. Okay, so so these are notes for some 513 notes, right? And so there's obviously, you can see there's a fair amount of math, and actually there gets to be quite a bit amount of math in here, right? So lots of stuff, diagrams, right? All this kind of stuff, right? You can just edit this immediately on the side like this. And so I can add things right here, like here's the first, second, and third isomorphism theorem, right? So I can just come in here and type, you know, here at alpha to beta. So you see that, and that should be an alpha, right? So you see here, there's this sort of language I'm using called LaTeX. Oh, someone's in our lobby there. Right. So this is right. So it's a kind of markup language, right, that you use for writing math. Very common for writing math, right? And you can use these kind of markup tools that actually just translate the math directly, right? So that's a thing. If you want to learn how to do some of that, I would be happy to work with you on doing some of that. It's quite useful. That's how all of my stuff is going to be. And I don't know if you look at the things I send you, I don't know if you can open up the edit side. You might be able to open up the edit side and actually see how the stuff is typed, right? So that's a thing you can do. But the part of my point is now with AIs around, right? You can write things in kind of a WYSIWYG version, right? And ask the AI to turn it into to LaTeX, right? And then you can put it into a thing like this, and it'll print up nicely for you. So the one I use is this HackMD. It just does this stuff for you. Where I make exams and stuff, I'll just open this up too. And then we used to have this, like now we have the MATLAB stuff. We used to have this as part of the class, right? So this overleaf, right, is a thing that just allows you to write LaTeX, right? So this is real. This is here. You have to know a little bit more about setting up documents and stuff. Although it does give you templates to use. In here, you're doing the same sort of thing that I was doing before. You need to know the symbols and stuff. Again, it used to be a lot harder. You used to have books and all these things. Right now, you can just go ask an AI and it'll tell you, right, what to do. But this is sort of typically how you do complicated math. If you're writing complicated math, you use LaTeX. One way or another, you use LaTeX. That's what it's designed for. It's designed for writing math. You can certainly just use Word, right? So you can use Word and you can use the math editor. So I don't want to force you to do any of this stuff, right? But I would say it's a good thing to play with and do it a little bit, right? Sort of, pick something, try everything, just to get some feel for it. I probably won't dock you anything for not typesetting the whole thing. We don't even say typing, we would say typesetting, right? Someone said, why doesn't so MATLAB, yeah, it doesn't quite do this. I mean, there's a version of MATLAB that kind of uses, you can use Python and you can use something called NumPy, and Python does it really, really well, right? Like I can make automatically generated exams with Python that generates the LaTeX and everything else. It's just a matter of, this is just a learning curve that's kind of off to the side of doing the actual math, right? Like how to write math, how to present math and stuff like this, right? So that's, and usually I have to say, usually students like in grad school have to learn this themselves. It's not usually courses in how to do tech, right? You're just usually thrown into it and say, learn how to do it, right? So it's kind of what I'm suggesting. I would suggest nowadays you can use, again, you can use AIs to help you out with it, right? But also you can ask me. I mean, I know a lot about LaTeX, using Python to do it. I don't know as much about doing it in Word. I mean, that's where I'm the late learner, right? There's a few things you can do in Word, and maybe some of you know this better than I do. So if I open up a Word document, you can do something like this. Let's see if I can do something like so let's say I want to do x squared plus 2x minus 5. So just something like that. Whoops, that's supposed to be a minus. All right, and I think I can highlight it and press left alt equals. and it turns it into math for me, right? And then I can say show professionally, and it sort of typesets it for me, right? So I mean, there is the option of just doing this. You can say insert an equation, right? And you can do it like that. But you can just type the math using a little bit of this LaTeX-y stuff. Let me see if I can do one with alpha. Like, let me try the same thing I did before. So alpha 2 is just an arrow, right? A left arrow. And then beta is just beta, right? So that, maybe you want to write that for doing some math for some reason. And I can do this thing, and it sort of did that. And let me see if I say make it professional, and then it almost did it, but not quite. So now I have to go in there and like put my cursor there and hit enter, right, to make it happen. Anyway, typing math is a pain. I mean, I'll agree with that, right? So typing math is a pain. So maybe don't try to do it for everything, but just try to do it some, right? Try to get some feel for it, because someone might ask you to do a lot of it, right? I'm not going to ask you to do a lot of it. I want you to do, like on the math part, I want you to learn the math, right? So if you feel like doing it by hand, that's fine, right? And I really like things like pictures and diagrams and stuff like that. And so if you want to do that, I mean, often that's easier to do by hand than it is to type up, right? Or to make pictures and include and things and stuff like that. Okay, good. Well, that's definitely one thing I wanted to talk about. Any questions about that? Any additional questions about that?
Can you say the two platforms you used other than AI again, please?
Yeah. So I mean, in the notes that I sent you, right? I mean, maybe this is the easiest thing to do. So can you go to the notes I sent you? Those are in something called HackMD. So that's free. You can use it. It's a markup language. So MD stands for Markdown. Okay. And see if you can open up the editing side. I don't know if you can see the type side. I don't know if you can or not when I share it with you, or if you can just see the presented side. I'm a little curious to know the answer to that too. All right. So again, if I go,
I'm checking the notes to see if I can do it.
So let me find your class. So your class is here. So like, here's your notes. Right. So these are the notes I wrote, and here's the actual markdown stuff on this side, right? Do you have the ability to change this to edit? It's like, see, there's an edit only, there's a split view, and there's a C, right? So this is what you see when you click on my link, but can you click on this edit?
It lets you see the edit, but it doesn't let you actually change anything.
Okay, well, that's probably good. I don't really want you changing them, but you can sort of see what I'm doing, right? So as a method of learning how to do some of it, you can do that. And then you can just open you can do your, you can, maybe you have to sign in, it's free. And then you can just create a note and you can start doing stuff on your own, right? It's really good. I use it, for example, if I just want to type up something quick and I want to paste it. So like I want to make a matrix, maybe a matrix is, here, let me do some sort of weird integral, right? So, int. Okay, so there's some sort of integral, right? Oops, not in is that int, right? And then another thing that I do sometimes is just I use this for making math, and then I'll like take the little snipping tool and like cut it out and then paste it into documents, right? So that's another thing you can do, right? So you can use this for just making the math. Anyway, I don't want to dwell on this too much. It's just some ideas, right, to get used to. It would be good for you to learn some LaTeX. Again, we used to have LaTeX as an actual component of the class. It's just no longer a component of the class, but it is a good thing to know. And even if you're using your MATLAB and you're typing stuff in MATLAB, it still uses LaTeX sometimes. So that's the next thing. So let me just make sure. So we're in an hour already. So let me make sure there's no other questions about the notes or the homework. And then I want to sort of look at the MATLAB stuff for the people who haven't done it. Lots of you have already done it. But any additional questions about that other stuff?
I have a question about some feedback that I got on the homework. How do you create ordered pairs from sets of home?
Okay, that's a good question. How do I get this view? Yeah, sorry, I don't know how to do that. Okay, anyway, I think let's go back to this screen. Okay, so yeah, this is a good question because mathematically, like, what is an ordered pair? What do you want about an ordered pair? We tend to write things like this, A, B, right? So what do we want? What properties? See, we need to axiomatize what we mean by ordered pair, right? So like, what is a set? You really write down some axioms and say, well, a set is whatever it is that happens to satisfy those axioms, right? When you get to abstract algebra, like what is a group or what is a vector space, like in linear algebra, where it's anything in a set that happens to satisfy the axioms of vector spaces, right? So what do we want about an ordered pair is we want that if AB equals CD, right? What we want to happen is we want that A equals C and B equals D. In fact, we want this to be if and only if, right? We want this ordered pair to equal that ordered pair if and only if those two things hold, right? Can we all agree on that? Okay. So the question is how to do that with just, and notice that this isn't true for sets, right? So, you know, 1, 1 equals, I mean, yeah, equals 1, 1 because, you know, 1 is equal to 1 and 1 is equal to 1, right? But if I look at sets, 1, 1 is just equal to 1, right? Okay, and also like 1, 2 doesn't really have any order, right? It's equal to 2, 1. Right, so we don't want that of ordered pairs or even more general n tuples, right? We have n many things in a tuple. So let's talk about that too once we do the ordered pairs. So what we want is some way of constructing these things with sets, okay? And I think one of you went out and found the typical way of doing this just with sets, and so I think it's due to Kuratowski. Who is it that did that? One of you went and found it and actually wrote Kuratowski's set thing. By the way, I can't fit all of you on one screen, so I have to flip. Anyway, one of you did that. I can't remember who it was. So I'm going to tell you, Hugo and Tringle, you're the two that are falling off my screen right now. I can't fit everyone on. Let me see if I make it wider. That doesn't matter. Anyway, the one way of doing this is this. So I can write, so I'm wanting to define something AB. Was it just that? I think this is right. Yep. Okay. So I think I'm going to define AB is equal to just over there, right? So I'm just using sets, right? So what I want to know is I want to know that this holds, right? So I want to know that. So I want to know that AB. So this is another good proof technique thing, right? I want to know that AB equals AC. Sorry, BC. If and only if A equals B, and sorry, A equal. Let's try this again. AB equals CD. If only A equals C and B equals D. Right, so I want that to happen. Okay, so so here's one thing, right? This is an if and only if thing. So this direction, okay. So we're wanting like trivial implications. I'm gonna say that's a trivial implication, right? So if we know that A is equal to C and B is equal to D, right? Then we definitely have that AA, AB, right, is equal to C, CD, right? Because A and C are just the same. So singleton A is the same as singleton C, right? And the pair AB is equal to the pair CD, right? No matter what they are, because A is C and B is D, right? Does that make sense? Okay,
yeah,
so
I don't understand the relevance of the AB equals CD part at the top. Like, why is that part necessary in this process?
Because you got to say what you want from an ordered pair, right? We're trying to get ordered pairs. I mean, you don't usually say that 0 is equal to the empty set either, right? But we constructed the numbers by defining them with set theoretic objects, right? So then we defined 1 to be this thing, and then we spent some time just a minute ago doing all that stuff, right? So the point is we're trying to represent these things that we think we understand, right, by these other things that are sort of the formal mathematical building blocks of you know, set theory, which is what we're using for the underpinning of everything else, right? So that's the idea, right? We think we understand what an ordered pair is, but we don't have a way of representing it yet. We need to represent it as somehow built up out of sets and somehow, right? So that's, and there's not one way of doing this. There's actually many ways of doing this, right? But my point here is that this direction was trivial. If I know that A equals C and B equals D, then I automatically get this, and this is just saying that AB equals CD, right? Because by definition now, that and that are the same thing, right? So here we're just unpacking a definition and using some basic facts about equality, right? So we are using some logic of equality. The logic of equality is if I have things that are equal, I can substitute them into expressions and don't without changing the value, right? So there is actually some axioms of equality we're using there along the way. This direction requires some work, right? So I'm going to say suppose that these two are the same. So I'm saying suppose AB equals CD. Okay, this is actually a great example for doing all sorts of like proof techniques. So what does this actually mean? So we unpack the definition. This says that this has to happen. This is, again, this is just the definition of the ordered pair at the moment. And as soon as we show it satisfies what we want ordered pairs to satisfy, we can use it, right? So then we're game to use it. Okay, so this is my assumption, right? So that's my assumption. What do I want to prove? We want to show, sometimes it's very good to just say what it is you want to show. I want to show that A equals C and B equals D, right? That's what I want to show, right? So that's my goal here in this proof, okay? So what does it mean to say that these two sets are the same? Well, it means to say something in here is in here and something in here. Everything in here is in there and everything in here is in there, right? That was the sort of extensionality of sets, right? That having the same elements is what you mean by saying two sets are the same, right? So if everything in here is in there, then there's kind of two cases, right? So there's case one is that so A has to either be singleton C or it has to be singleton CD, right? It's got to be one of those two things, right? So let's first assume that it's singleton. Let's say that singleton A is actually CD. All right, so that's right. So I'm taking something in here. It's got to be in there. So it's got to be one of those two sets, right? But if this were true, then what is that telling me? It tells me that these have the same elements, right? But that would tell me then that, so this would imply that A equals C equals D, right? Because the only thing in this set is A, right? And if these two sets are the same, then this has to be the set, just singleton A, right? So these actually have to be the same, right? So in this case one, I'm actually in a case where C and D are the same and A is equal to both of them, right? So I can go back now and say, well,
what's that at the beginning of that sentence?
Oh, sorry. This is case one. Is that what you're asking about?
Yes, sir.
Yeah, case one is that, right? Okay, so now I'm in this, so now I can take my original thing I had was like this. But I've just shown that A is equal to C and D, right? So C is just A, right? And C and D are also just A, right? So I actually have all of those are the same, right? And so what does this now tell me? It tells me that this set AB has to be one of those two sets, but those are the same. This is really just singleton A, right? Like that, right? But this, okay, but then this AB has to be that too, right? So A has to also equal B, right? So in this case, right, in this case where A is equal to CD, so we're in this case, that case right there, right? Then what we're actually getting is that we're getting that A equals B equals C equals D. They're all just the same, right? They're all exactly the same things. Okay, and so in that case, what do we have? We have that our original pairs are just these guys. Right, but then it's clearly the case that A equals A and A equals A. I mean, there's just nothing to show, right? In other words, in this sort of degenerate case where this is what happens, right? What we're really looking at is just this is the pair AA and that's the pair AA, and so A and C are the same because because they're the same. We proved that, but also B and D are the same because they're also just A, right? So this is just reducing down to the case where these two things are really just AA and AA, right? So it's kind of a degenerate case, but it is a case. Okay. I mean, so we really showed that everything is just the same here, right? I wanted to show that A equals C and B equals D, but we actually showed that A equals B equals C equals D. They're all the same, right? So we got what we wanted. So case 2 is going to be that A does not equal, this is the more interesting case, CD, right? Remember our assumption is this, right? So if singleton A does not equal CD, then singleton A has to equal singleton C. That's the only option it can have, right? Okay, so singleton A equals singleton C. All right, but what does that mean? That means, so A equals C. Again, I'm not writing this great, but we have that A equals C. That's one of the things I wanted, right? So now I have that A equals C. So going up here, so rewriting this again, I've got A, AB equals, so here's what I started with, right? C, CD. This is my original assumption, right? But now I've got that A equals C, so this really turns into this. A, D. Right? So AB has to equal AD, right? A doesn't equal this AD, so it must be that AB is equal to this AD. Right? Okay, so AB equals AD. Right? But A is A, so B has to be one of those two things. D can't be, A can't be A and D. In other words, D can't be A. That was case 1, right? That's not happening, right? So it must be that D equals B. Right? That's the only possibility there. D can't be A, so D has to be B because these sets are the same, right? So these two sets have to contain the same elements. Well, they both contain A and they both contain D and B. But since D isn't A, right, it must be that D is B. Okay, so we have D equals B. Right? And so we've got both of those two things. That's what we wanted, right? So think about it. I mean, I'll post this and you can re-listen to that again, right? It's not written well. If I were to write it up for you and try to make it all pretty, right, I need to write it up better. But either way, what we did here is we showed that this happens. If this holds, if that holds, right? Now we're defining this thing up there to be that. So we're saying if that holds, right? Then we have that A equals C. And that's all we wanted from our ordered pairs, right? That's what we wanted our ordered pairs to do, right? That was the important thing.
Yeah, I follow for the most part. It'll probably be something that I have to go back and look at again, but for the most part, I did follow what you were saying.
Yeah, so I mean, you should work through it all again, right? But that's what we wanted. And once we have ordered pairs, we can then go on to make ordered 3 tuples. We don't have to. We've actually got lots of options here too. Let me look at 2 of them. One thing would just be to make pairs like this, because we already know how to do pairs. So now we could do, that, right, for our 3 tuple. Right, and then to make an n tuple, we could do, if I have A1 through AN, right, we could do it kind of recursively and say, well, that's going to be, this n minus 1 tuple together with AN. Right, so you might do something like that. Right, so there's lots of options here. Let me say another option is this. Once we have the notion of ordered pair, we can have the notion of, right, the product of 2 sets. Right, we can have this. Actually, let me use a different notation here. I'm using A and B, so let me do that. I mean, now I'm going to do stuff that's kind of high school algebra-ish on you. Right, so A and A, B and B. right? So once I have the notion of ordered pair, I can look at the product of two sets because I can define all those things, right? Once I have this, right, I can start looking at the notion of functions, right? I can look at a relation, which is a subset of A cross B, right, with some properties, the property being that for all A and A, there is a unique B and B such that R A B holds, right? So usually we would write this R. So when we have a situation like that, right, this is really a function, right? So I could usually write this, you know, F of A equals B, if and only if R of A B holds. Right? So this is the usual thing when you're like teaching kids functions for the first time, and you're needing to teach inverses and all that sort of stuff, right? You look at relations first. You look at relations that are sort of single valued, right? Those are functions, right? And all you need to do that is you need sets, you need ordered pairs, right? Now we've got ordered pairs as sets, right? So we can define relations, so we can define functions, right? And once we define functions, there's another option for defining pairs like A1 through AN, right? I could define these as functions going from in to, you know, whatever it is whatever set I'm interested in, right? So those would be like in tuples. And this is, you know, very commonly the way we do things, right? And in fact, given what we just did, n is actually equal to the 0, 1 through n minus 1, right? So this is literally a set. So it's literally a function from those things to A, right? So instead of starting enumerating at 1, I might write A naught through AN minus 1, right, for that tuple. So there's really a couple of options. Once you have ordered pairs, you can just sort of recursively define in tuples, right? Or you can define the notion of function and then just look at in tuples as being functions from in to some set, right? So you've got those two kind of options there. So this is all about how you
Doc, when you wrote A naught, did you write 8 subscript 0, or is that an EN?
So yeah, so this is, yeah, so let me sort of say that one more time. So by all the stuff we're doing today, right, n is equal to the set 0 through n minus 1, right? So I could look at f going from n to some set A, right? And so this would be, so the things in the domain are 0 through n minus 1, right? So I could represent such a function. So what is that doing? It's taking 0 through n minus 1 and it's mapping it to some set A, right? So A 0 is being sent to A0, right? You know, n minus 1 is being sent to A n minus 1, right? So I can look at this as a tuple, A0 through AN minus 1. Right. Good, right? So like we would usually write this as A to the n, the set of all n tuples, right? So this would be like the set of all A naught through AN minus 1, A, I, and A, right? But we could also write this as the set of all functions going from n to A. You know, f is a function. Right? So those are equivalent ways of doing things, right? So this is a lot about how you can code things in the language of set theory, right? In actual practice, it doesn't matter how you code your n tuples, right? For the most part, you just do them however you want to do them, right? But here you're seeing for the first time maybe how you can code them in the language of set theory, right? So that's part of what you do when you get into the higher math is you're learning some of the foundations of stuff, right? And yeah, I know it's worth knowing, right? It's worth sort of thinking about. It also gives lots of examples of proof techniques.
Dr. K, I had another, just one more homework feedback question, but I do want to allow, if anybody else has a question, I want to give you guys the opportunity.
I bet I know what it is, but yeah. Does anyone have any more questions about this, or something else? I did give some of you feedback on the homework, so any questions about that?
Let me be honest and say I was following things sequential and I haven't even gotten to the homework because it wasn't in the sequence. But now I realize that I need to make sure I do the homework before Monday, even though it's not due until Wednesday.
It's really good to look at it before, because that's what we have to talk about largely, right? I mean, you can just listen to me lecture, but you know, that can get, if you haven't thought about it ahead of time, that's probably not the best. Like the best thing would be to have looked at the homework. So we can talk about that too, right? And I do try to grade what I can get graded before the class starts, right? So I bet your other question is about the proof by contradiction.
It is. I just wanted to know, it's been a while, and
Mm-hmm.
I just wanted to, not so much because I understand the proof, it's
Mm-hmm.
more so the setup, like what would P be, like the overall setup of how you use contradiction using
So
just P and Q.
So everyone who gave me a particular argument did a pretty good job, I think. But it's exactly this point you're saying there, right? When you're trying to justify what you're doing, that a confusion is going on, right? So in fact, it's really easy to just say what you're trying to prove at the end there, right? So let me take the example I think you maybe had, which was that square root of 2 is irrational.
Right.
Okay. Now, this is a little different than what the question asked, because this is not of the form P implies Q, right? Which is what the question particularly asked about, right? This is just of the form, say, Q, right? That's my Q, right? Period. And the way a proof by contradiction is going to go is I'm going to assume, I mean, let's just do it in English first, sort of, assume not Q, right? And then you do some work. So you do some stuff, right? So I'm not going to redo that stuff because I think it's either good for you to think about, or, you know, if you haven't thought about it, or you know, I mean, the basic thing is you say square root of 2 is equal to P over Q. Suppose that's true. And then you say, you know, P over Q is in reduced terms, so there's no common primes. Yeah, I'll just do it. Okay. I think everyone should know this, right? So
I'm sorry, I didn't mean for you to do this. So yeah.
No, that's fine, but I want to get to the other, to the main point, right? So so yeah, assume not Q. So I'm assuming that square root of 2 equals P over Q. Right, I can assume that these P and Q, so GCD of P and Q is 1, right? So they're relatively prime. So you've canceled out all the primes in common to the two things, right? And then we can square, right? So that we get 2 is equal to P squared over Q squared, right? And then I can get 2Q squared equals P squared. Obviously, here's a place where I'm not writing down the justifications, right, for each step, right, along the way. Okay, but what does this tell me? It tells me that 2 is prime, right? And so 2 divides this side, so 2 must divide that side, right? So 2 must divide P squared, right? But the only way a prime can divide P times P is if 2 divides P. This would imply that 2 divides P itself, right? Now maybe there's something to say there. So if Q is, I've got Q, I've got all these letters in use. If R is prime and R divides ST, right, then R divides S or R divides T, right? So that's either your definition of prime or it's a fact you know about primes, right? It kind of depends on what you consider the definition. But if 2 divides P, right, then P itself is equal to 2P prime, right? And that means up here that I have 2Q squared is equal to 2P prime squared, which is 4P prime squared, right? But now I can cancel out the 2 and I get 2 squared is equal to 2P prime squared. Okay, but now 2 divides this side, so 2 must divide that side, right? So 2 must divide Q as well, right? Okay, but look, 2 divides Q and 2 divides P is a contradiction to the fact that P and Q are assumed to be relatively prime, right? We canceled out all the primes, right? So we have a contradiction, right? Our contradiction here is, you know, 2 divides Q. Whoops. Sorry, my phone is talking to me. I don't know how to stop it. Hold on just a second. my phone thought I was asking it a question about primes. Started answering it. Right. So we get down to the end, we got a contradiction. And let's not worry about exactly what the contradiction is. Let's say, I could just say we get false, right? Right. So let me just do it like that, right? So what I've done is I've started with not Q. I've done a lot of work in between. Now the work in between wasn't for free. It used some number theory, right? I mean, it used some stuff, but no, that's the stuff we get to sort of just assume, right? And we proved, so this is the sort of the formula, the thing for prove. We proved false, right? Okay. Or in fact, let me do it so it doesn't look quite so strange. Let me say we got a contradiction. It looks like not C and C, right? So that's the way I'll write false. Just to make this a little bit more clear. Right. But what that means, right? So we started with not Q and we proved that, right? Just using the rules of logic, right? Okay. But another way of saying that is we could just prove that not Q implies not C and C, right? So these two things are equivalent to each other. So that little equivalence is kind of written in the notes, right? So saying that I can prove not C and C from not Q is the same as saying I can prove that not Q implies not C and C.
That's De Morgan's law, right, or no?
No, this is really just sort of the definition of this turnstile, this proof thing, right? I mean, there is a definition of being a valid argument, you know, having a conclusion down here, right? And so saying that this was a valid argument, another way of writing that is just writing A1 through N proves B, right? But by definition, what this means to say this is a valid argument is to say that this is a tautology. So now this is in the notes, right? Right. So this is really just a matter of definition. So this is one of those cases where I'm like some of you, and what you said, what a trivially proving things is because you're just unpacking a definition, right? So I just unpacked a definition. So according to some of you, I just said something trivial, right? Now, and one of the comments I gave is that is not always trivial, and maybe this is a good way of seeing that that's not always trivial, right? It's not always trivial to unpack definitions, but these two things are the same. These just mean the same thing. This means I can prove that, right? This means that this proves that, right? So it's really just kind of two different ways of saying the same thing, okay? But we have this, we also have this. Do I also know that not C or C, right? I also know that, right? That's the excluded middle, right? So this is one of those places where maybe you want to write down what you're doing. Right? If I just look at not C or C, that's always true, right? So I know that's always true. Yeah. Good. Yes.
Yes, I'm trying to. So not C and C would be the false.
This was the contradiction we got. What?
Okay.
Yeah. Whatever the contradiction. So I haven't said what it is, right? It's like 2 divides Q and 2 doesn't divide Q, something like that, right? Whatever that was in that case. Just some contradiction. I could just use F for false, right? So I could just do that. And then instead of assuming not C or C here, I would just assume true, which I could also do. I can just assume true. It just sort of seems better to use excluded middle at this point, right? So we have those two things, but we also have this. Oh, and then from this, right, I can actually conclude that not C and C. Right? Why can I do that? Well, that is De Morgan's law now, right? So that's just De Morgan's. Right? And then from that, right, I have this. I have not C and C. And I have this, not Q, implies not C and C. Right, so this is what we did in our proof by contradiction, right? So now I'm explaining why proof by contradiction works, right? Okay, we have this for free. That's just always a tautology, right? We prove this. Okay, this wasn't for free. This used some number theory in there, right, along the way. But now we've got this sort of thing here. So if you look at this, it has this form. It's like not phi, let me call this, so psi implies phi, right? It's got that form, right? So not something, and something implies that something, right? So it's got that form. So this I'm calling phi for a second, right? But this now is just literally what you have in modus tollens, right? So once I have something like this, I get to conclude not psi, right? So this is modus tollens. Right, so in other words, from this thing up here, I get to conclude not Q, right? Because of this, right? And not Q, of course, is just the same as Q, right? So I can conclude Q, right? So this is this is where the real sort of crux of the thing comes in, right? From these two things, right? So let me just put false back. So if this thing I had just written down was false, right? This thing would just say true, right? So I just have basically true and not Q implies false, right? Implies Q, right? I mean, that's really sort of the heart of the argument, right? This is the contradiction. Okay, that we derive from not Q, right? Whatever the negation of the contradiction is just something that's always true, right? It's a tautology, right? And then we get to derive this is modus tollens again, right? So that's really that. I mean, again, what we're really deriving here is not Q, right? From modus tollens. All right, remember, if you look at the notes, right? Modus tollens is this P and Q. Let's see, how is it? I guess it's like this. Let me try to get it right. Oops, sorry. P implies, dang it. P implies Q, and not Q, right? Implies not P, right? That was modus tollens, right? And so that's what we're using here. And I'm getting not Q, but that's the same as Q, right? So I'm even using that extra little fact that not Q is the same as Q, right? But this use of modus tollens is really the key right there, right, to the proof by contradiction. So think through it again, right? I mean, I'll put this out there and you can listen again, but think through that whole thing again, right? Because that's the key to seeing why the proof by contradiction works formally, right? Kind of. Okay. So I've lost track of my chat. Someone asked, it's overly free. Yes. I don't. Oh, you asked that a long time ago. Okay. Okay, good. All right. So I think that's probably enough of this for now. What I'll do going forward is we will have less grad study stuff and more math, right? So like I'll put out half of the math lecture in the video and notes, right? And then we'll spend, and I'm going to sort of assume you've read that and looked at it, and the other half or some we'll talk about in class, and then we'll work through problems, right? So that'll be sort of the way the classes go. The one other thing I wanted to do was look at the MATLAB stuff. I guess maybe I could just ask this question. Does anyone have questions on doing the MATLAB, accessing the MATLAB, any of that? I mean, that's kind of the thing that I would like to get out here. Maybe I'll open up a window here. Let's bring this down.
While you open up that window, can I ask you a quick question, Dr. K? With the homework, I'm looking at your notes or whatever. I'm just not realizing that you had the little side screen. I guess, did you use Greenleaf for that to do that worksheet for your video thing? You use Greenleaf, that coding. You use Greenleaf for that.
For that, I just use the HackMD site.
HackMD.
So if you go to the notes itself and just look at the web address on the top, right here. Let me go open up one.
I'm on it. I'm doing both. I've been looking at that for the longest. Okay, I see it at the top. HackMD.io. What's the name?
Yeah, so
That's what you use?
that's what I use for making quick notes. If I want to make more formal stuff, I'll use Overleaf, which is just plain LaTeX, right? So usually when you open this up initially, you might have to log in. You might have to use your email or something, like Gmail account or something to log in, right? And then you can just like create a new note and start typing. And it has a lot of, actually, I should send you a link to the features page where it just shows you how to do a lot of stuff. So you can embed videos and you can make things. I mean, like if I want to make something sort of a main title, I can just do it like that. If I want to make it a subtitle, I mean, this is all pretty standard stuff. I want to make a subtitle. Right. It does all those sort of things for you, right? If you want to embed a link, like I'll just, let's see. So here's this MATLAB site, right? Whoops. Go away thing. I can't see. Sorry. This thing in the way. So, right. So if I want to like embed, so like there, I can embed a link. Whoops, I didn't want to do it like that. Sorry, there's the link. I want to do it like this. Right, and so now it's a link. I can click on it, right, and it'll take me to the site, right? So I mean, it's just a very useful way of generating pages. It's really useful for notes and things, right? So and it's really useful for just because it does math really well, right? Anyway, going back to this, right? So here's the MATLAB thing. Everyone access this. There was a link in Halo. Is anyone having problems with this? Is there any reason for me to talk about the MATLAB at all? If there's not, I don't have to do it.
Do we have to use the MATLAB in any of our classes for
Yes.
them? Do you know? Okay.
You have to use it a lot in linear algebra. Okay. And MATLAB is really, the language is matrices, right? That's sort of the language of MATLAB. So it's really, really used for linear algebra stuff. And then you have to use it, depending on who's teaching, you might have to use it in 571. I don't have students use it in 513, which is the abstract algebra. But then when you do modeling, you have to use it in modeling, and you have to use it in the statistics. Okay. So yeah, the short answer is yes, you have to use it for things.
So we do have to get very familiar with it and make sure we remember how to properly type everything in.
You should. So in this class, you're just going to familiarize yourself a little bit with it, with this MATLAB online thing. Who knows? Maybe I'll do some other things that just to keep you engaged with it a little bit. But then in linear algebra, maybe even in the history of math, I think they do a thing about the role of computers in mathematics in there, and I think maybe there's a MATLAB project in there too. Linear algebra, you have weekly assignments in MATLAB. Those were created by me, so they're heavily templated. So there's basically a template you have to fill out, but it does leave you quite a bit to do. So there is stuff to do.
Okay. Thank you.
Yeah. Of course, always ask questions. And again, with this stuff, nowadays it's pretty easy because if I want to know how to do something in MATLAB, I go to GPT and say, how do I do this in MATLAB? Right? And I try to do it and it doesn't work quite right. And I say, here's what happened. And it says, oh, do this, right? So you can really kind of do things for coding. You can do things pretty easily using these AIs these days.
Yeah, I think within MATLAB, they also have the help function that'll kind of help you with whatever you're trying to do as well. And then I believe, I could be wrong, you could go to a particular part of the kind of tutorial to what it is that you're needing help with, and you can just redo it and it'll walk you through how to do whatever you're trying to do.
Let me show you one thing. Oh, I think I'm logged in as me. Let's see, how do I get to my, I want to actually go here. Let me open up something. I forget exactly, I was like, okay, here's an interesting one. Let me open up that one. If you use the MLX sheets, so the live scripts, right? Then what you can do is you can just sort of run them. You hit shit. Oops. No, I guess what do I need to do? I guess I just need to hit run section, right? Run section. So it runs some stuff. Run section, run some stuff. Okay, right. And it starts doing things. So the thing is, you can put your code in here, and the things you're actually doing sort of start appearing over there, right? It's really convenient to use these live sheets. So I forget exactly what happens here. This is actually one of the linear algebra things, right? So there's lots of stuff that happens in this one. Yeah, I mean, so this is one of the linear algebra examples here, right? But if you use these MLX version, if you use the live, let's see, it's called, let's see if I go new, how do I get back there? Yeah, new live script, right? If you use the live script, then it's kind of like you have your work you can do over here, and the results show up immediately over here, and it's really quite nice. And then at the bottom, if you want to define functions, you can define functions down there. It's got to be in the very last cell, and you can define functions. If you're just using plain old MATLAB, you actually have to use different sheets for different functions. You have to define one function per sheet, and then kind of keep things in a directory. It's kind of a pain, right? But if you use this MLX, this live script thing, then you can just put all your functions at the bottom and do all your work up here, and it all stays in kind of one nice sheet that's easy to use. So if you haven't used MATLAB before, I would strongly suggest using the live sheets while you're doing it. And then it does all the plotting and stuff. Again, so this is like a template you get in the for one of the problems in linear algebra. So I ask you to do some stuff with this stuff there, but all this templated stuff is already there. So there's an awful lot of stuff given to you, and then you're just asked to do some extra stuff. Okay, but it is used. But I guess my question right now is just, is there any questions about just accessing it? I think a lot of you did it already. So are there any questions about just accessing MATLAB, doing the thing, and okay. Otherwise, I would say don't worry about it till you need to use it, to be honest, right? Unless you want to use it. I mean, I learned how to do this coding stuff from teaching. I mean, I wanted to make pictures of things for calculus classes and stuff, and this is how I learned how to code. All right. Good. Let's see, was there anything else?
I have a question, Professor. So even though I did take notes, I followed all your notes, I watched all 3 videos that you told us to watch, and I took notes on that. My understanding, just so moving forward, is even though the homework's not due till Wednesday, it would be advantageous to take care of the homework, or at least attempt the homework prior to Monday class.
Definitely, yeah. Okay. Because it's much more useful for you to ask questions about things you're confused about, right? Than to just hear me talk, right?
Confused by your videos, but I kept rewatching them until I got to the point where I felt I was at mastery and I could follow it. Mm-hmm. So I'm hoping that that'll lead you through the homework, but I understand the videos that you embed in the notes are excellent, and then it makes the notes make sense. I just want to understand the sequence of how to calendar my weeks out. That's all.
Yeah, the more you can try the homework before coming, the better, right? Because then you can ask me questions. I mean, otherwise it's just me talking about the stuff. But if you've tried it already, then we can work through issues you have. And then I put that extra homework forum. I don't know if you've seen that yet, but in Halo, I put a homework 1 forum, and I put some of my comments, some of the stuff we were just talking about in there. In fact, the thing I was just doing with the proof by contradiction, I have some little notes in there about that now. And you can post questions in there, which you guys can answer to each other, right? Or you can, and I'll jump in and look occasionally and answer them. The one thing I don't see is if you don't reply directly to me, I don't see that there's new stuff in there, right? So when you reply to each other, like if Carl replied to Jordan, right? Jordan would see that someone responded to him, right? But if Carl replies to LaDonna, Jordan won't see that Carl wrote anything to LaDonna, right? Does that make sense? So if you want to grab my attention and say, hey, something's in there that I need to look at, you kind of need to put it in as a reply to me, right? Or at least put it in as a reply to me to say, look at this, right? And if I'm ignoring something long enough, you might just send a message through the messages to get my attention. Okay.
So for just clarification, what you're saying is the 3 posts that we're required to do weekly, 1 per person per day, you're not even aware that we've done
I'd have to look to see that. I mean,
Yeah, your computer is acting up now. You're like got robot voice.
okay. Answering me.
It's going in and out.
Let's see. Let me try.
You good now, Dr. K?
Can you hear me now?
Yeah.
Yeah, I think it's better.
Okay, so we're about to end anyway, but in some classes, it's really important for this kind of just talking back and forth participation. They really consider that important, right? In this class, I'm really interested in the math, right? I would love you to ask all sorts of math questions and talk to each other about math. That's great, but I'm not going to, in terms of credit for the class, I'm not going to hold that against you if you don't host 6 times or whatever, right? And I probably won't be marking them substantive. I mean, everyone will get all the participation points as long as you come to this thing, right? And then if I give you the little reading quiz, as long as you do that, you'll get all the participation points.
So for clarity, we don't have to respond to 3 people. We good.
Not in terms of points. I mean, your advisor might be looking in to see that you're posting stuff. So you might just post some stuff. You know, if your advisor bugs you about it, post some stuff, right? I mean, GCU is sort of a funny place, right? It's very top heavy, right? It's got like layers of administration, and then I teach the class, and there are people that look to see that I read things a certain amount of times and that I respond a certain amount of times, but they don't have any clue what we're talking about, right? They're just looking at numbers of responses and numbers of things like that. So if your advisor doesn't care, then it doesn't matter. You'll get the participation points. You do care about the points, right? But if your advisor does bother you and say, hey, you haven't been posting 3 times this week, then just post 3 somethings, right?
If admin walked in, look busy, guys.
Yeah, sort of like that, except you never know when they're walking in. They walk in, you know, through some sort of machine that's keeping track of you or something, right? Anyway. All right. Well, I mean, we can end a little early. We had a little less math this week than next week. Any last questions on anything, or if someone wants to hang out and ask some questions with a smaller group, that's fine, because we still got like 10 minutes.
So if we start, because it's not a big if, because I need to start the homework. Will I be able to have any? Do you have office hours where we can video chat with you other than like on Monday?
So if you look at the announcements, right, I have a little post in there. I forget exactly. Actually, now I forget exactly what I posted in here. Let me see what I posted. I know I must have, because Jordan used it. Let me see what I posted. Jordan, you found it. So where did you find it at?
What are we looking for?
How you found to get together with me to meet, because you did that. Where did you find that?
You have to go to, like, it's not in Halo. Like, just when you log in normally, go to that email, and that's where all the links for the meetings go. Is that what we're talking about?
Right. No, you scheduled a meeting with me through bookings. Where did you find that? Was it in my bio? I'm not sure where you found that.
Yeah, hold on.
That's on your syllabus. I know where that is. I studied your syllabus. I know where it is.
Okay.
I don't think it's on the syllabus.
There's a way where it says contact your professor, and you can go in and schedule something. I just remember because I went into detail of reading all that.
Let me show you the.
It's in your discussion post, your intro post.
Oh, it is. Okay. It's also in my bio. So if you go, this is the class. Maybe that's what you're saying, right?
Yeah. Yeah.
So if you go to this introduction, right, there's that book a time with me thing. And so you can schedule a time that way. So that's a way of getting some separate private office hours.
I was just really asking for your office hours so that I could be respectful, though, if you have office hours.
Well, I mean, those are set up. Okay, so my job is teaching online, right? So I'm really teaching online all the time. I mean, I have like 100 Math 144 students. So I've got like 5 classes of those, right? So all I do is sit here and do stuff. So those times that I have scheduled for that bookings, those are good times for me, right? So it's basically just 30-minute sections, and it does a good job of giving me buffers on both sides and stuff like that. So it works out good.
Dr. K, when will you make homework 2 and all of that stuff available for submission?
So I'm not gonna promise before like the Thursday, sometime on Thursday, maybe if I'm lucky Wednesday night.
Okay.
Right. Shouldn't be too hard, but there's just so many, because like I said, I have 2 grad classes and they require a lot of time actually to get everything done.
No rush. I'm just curious.
Yeah. Good. And then the video probably also sometime on Thursday, I would guess, right? For the
I know this may be a general question, but does anybody know how to access our email account that's attached to the campus email address? Because I can't find my email.
Oh, I do know it. I can tell you. Sorry. Now I've forgotten who your name. You were Cammie, right? Tell me again.
Crystal Morgan, not the Morgan, but the Morgan. A Morgan.
De Morgan. Crystal De Morgan.
No, not the A Morgan.
Okay, your email is cmorgan105. Here, I'll just copy this.
I know my email address. I just don't know where to go to find my email. Like, I didn't see that video in the video when we did the videos. It didn't show where to access your email address, and I've perused the entire, and I'm like, okay, where is email?
When you open your like student portal in your My Apps, there's an email app. And when you click it, it goes straight to your Outlook. Just make sure you're signed into your school account. If you have like a work account on your computer too, you'll have to sign out of that one and sign into your school account.
Where's the student
Sorry,
portal?
you cut out. What's it? So the new portal.gcu.edu, the website where like you go to get into like your classes and stuff.
Mm-hmm.
If you look on your page, there's an app section, and if you don't see the email app, you can do edit apps and add it in.
Here, let me stop sharing mine. Do you want to share your screen and just show it real quick?
Yeah.
I see apps as an option of mine.
I think you can share. See if you can share.
Oh, there it is. We're just gonna share. No, wrong page. I'm gonna choose the right one so y'all can see what I'm doing. Share that one. So like when you log in and you see like, hey, this is my class and I can open up, there's these apps. And if you don't see the email one, you go over here to edit and it'll be somewhere in there, or you can hit add and then just search for which one you want. I think you're muted.
Crystal, you're muted.
Can you do that again? Because I'm pretty sure I don't have that, and I did all of that. So I would appreciate it if you just start from the beginning.
Yeah. So as soon as I like open my main new portal.gcu.edu, just go in like I'm going for my class. You know, like I see my class over here, and then there's an app section, and it'll say my apps.
Are you on the website newportal.gcu.edu? Crystal?
Let me
sign out, Cassandra, and then sign all the way out and close your app out, close the page out, then sign back in so you can go back to the original page, because that's how it started off. Do it that way for her.
And I sent the website in because make sure you're in the right one. And so when you go in and you're ready to log in, like I have a work email. So I have to make sure I hit my GCU email. Otherwise, I don't get my GCU stuff. It'll give me my work, like it'll give me an error code, and then on my thing, it'll only show my work stuff. And
you got to go through all this stuff.
It's okay. And then when I first load it up, that's like the dashboard. And I sent the link in the chat in case you were using the old portal. Got it? All right, beautiful.
Good. Okay. Good. I'd never seen that portal before, so that's good to see. Good. Anything else? Any other questions? Anyone want to say anything else? It's a good meeting you all. Ready to do some math next week? Okay. Good. All right. Awesome. I will see you all later.
My son really wants to say hi.
Oh, goodness. Hi, cutie.
Hi.
Are you learning some math?
Yep.
Oh, there you went. Good. Okay.
I love the shirt.
All right. All right. See you guys.
See ya.
Thank you.
Thank you.
Bye-bye.
Professor, are you still there?